Hello, my name is Zach DeWardner, and today I'll be walking you through our automated model-based manufacturing system we like to call the LABFAB system. So without further ado, let's get into it. The parts are first ordered by the operator from our SCADA system, built within Inductive Automation's Ignition software. This ordering signal is then sent through our Raspberry Pi-based communication network via MQTT protocol and ROS pub-sub architecture to trigger the movement of our vacuum gripper robot, or VGR, and the high bay warehouse. As you can see, the high bay warehouse robot is in the process of picking our designated order to eventually make its way to our central VGR. As the high bay warehouse robot lowers the white part onto its conveyor, light gate sensors are used to activate the conveyor's motor and communicate to the vacuum gripper robot when the part has reached its pickup location. After being received by the VGR, the high bay warehouse robot returns the empty bin and subsequently updates an inventory log file to show the empty space. The VGR then brings our part over to the multi-processing station, or MPS, which is meant to emulate a kiln process for ceramics or for hardening metal. After finishing this task, a mini vacuum gripper carries our part to a rotating plate where a CNC milling process would take place. The CNC process is currently represented by the rotating spindle, as you can see here. However, in future renditions of the LABFAB system, we plan on replacing this with an integrated CNC simulator triggered through ROS communication. After milling has completed, the part is then ejected onto our primary sorting line, where it will pass under our first color sensor. The light reading is captured and used to establish which bin our part will be pushed into. Once the part enters the bin, a light sensor is interrupted, signaling that this part is ready for the VGR to pick it up and move on to further processing in the LEGO sorting line. Once the part is picked up from our primary sorting line, the VGR moves on to placing said part into the delivery and pickup station. On arrival, another light sensor is interrupted, signaling to the 6-axis cobot developed by Elephant Robotics that this part is ready for transfer to our secondary sorting line. The sorting line itself is constructed with LEGO blocks and are controlled via LEGO Mindstorm motors and a Raspberry Pi equipped with 2 stacked BrickPi 3 hats. This system is controlled outside of the ROS network via Sparkplug B connection to our SCADA system, where a sequential function chart dictates which path the part will take. Once the part reaches the end of our LEGO sorting line, a light sensor is triggered, activating our cobot for in-processing. The cobot will then carry our part over to a ramp leading back into the Fisher Technic side of our system, dropping it on another light sensor, which triggers the VGR to drop down and carry our part to the secondary color sensor. Once a value is obtained, the VGR communicates with our master Pi, asking for a free space to store the part. Once this is found, both the VGR and high bay warehouse robot begin to move to their respective positions for part storage. The remainder of this video demonstration shows how the process works for a red order. If you are interested in seeing the part retrieval process, you can skip ahead to 7 minutes 15 seconds. Otherwise, I'll be sharing more information about the system itself while the red part makes its way through. The LABFAB system has been continuously updated over the years as a capstone project for undergraduate industrial and systems engineering students. At first, there was only the Fisher Technic side, with all of the main robotic systems such as the high bay warehouse, VGR, MPS, and sorting line systems. This industry model initially came with complementary control and SCADA systems provided by the German company Fisher Technic. However, to add multiple levels of complexity along with supplying students with hands-on multidisciplinary tasks, the existing control mechanisms were removed and replaced with Raspberry Pis and FTDuino boards. This model-based system is used to provide students with an introduction to autonomous manufacturing systems, along with data-driven process improvement and IIoT data analytics. In the coming years, new technology will be introduced to the system, including new robotic arms to replace the legacy robots, new conveyor belts to replace the Lego sorting line. Machine learning algorithms for image recognition will be introduced to aid in part routing within our sorting line, along with RFID tags placed on all of our parts and antennas throughout the system so that we can run RFID localization to know where our parts are at all times. And lastly, the capacity of our high bay warehouse will be expanded from 9 parts to 100 parts.